Today we're going to be looking at some proportions within triangles. We're going to be looking at 3 different theorems, and they are all going to relate, or they're all true because of similar triangles or similar figures. Remember, similar figures, all angles are congruent and all sides are proportional, and that's the fact that sides are proportional is where these different theorems come from. So here we see the first theorem. If a segment with endpoints on 2 sides of a triangle is parallel to the third side, then it divides the 2 sides into proportional parts. So let's take a look at what that's going to look like. We have, and you actually see a lot of examples here in the problems, but if we drew a parallel line here to this third side, it says, then it divides the 2 sides into proportional lengths. So it's saying if this is A and this is B, and this is C and D, it divides the 2 sides into proportional lengths. So we could say A over B equals C over D. And that happens because this smaller triangle is similar to this larger triangle, and we can look through the proportions that are made up there. It would be A over A plus B equals C over C plus D, and then you can do a couple things to show why that's true. In fact, let's go ahead and look at that. So this is why it's true. A over A plus B, so that's the short side, the side of the smaller triangle over its corresponding A plus B equals C over C plus D. We're actually going to flip these fractions here because it will help us. We can work with a common denominator. And we know that if 2 fractions are equal to each other, then the reciprocals have to be equal. And now we have a common denominator, so we have A over A plus B over A equals C over C plus D over C. Well, these are just 1. We could subtract 1 from both sides. We have B over A equals D over C. And to get it in the form that I wanted, we can do the reciprocal again. A over B equals C over D, which basically says the same thing. The symmetric property would be, I know it does say the same thing. So that's how it's proven that those 2 are equal to each other. So that's the proof of it. So now we can use it. So looking at this number 1, we have these 2 sides are parallel, so we have 3 over 5. So I'm doing 3 over 5 is going to be equal to, what corresponds to 3? Well, the 6. So 6 over the question mark, which I prefer using x. So 6 over x, cross multiply. So 3x equals 30. Divide both sides by 3, and we get x equals 10. All right, coming to this, I want to look at some of these other ones. So actually, 1 is similar to number, oh no, it's not. They're all a little bit different. So let's take a look at this one. This isn't, number 2 isn't just dealing with the 2 sides that, or the 2 segments, as in 1, 2, compared to 1, 2. It's got some longer sides here. So actually, we don't even really need to use the new theorem. We can use the fact that these are similar triangles. So we have the smaller triangle, and then we have the larger triangle. And those are similar triangles because of angle, angle. So really we can just say x so x over, that's this side, over 40 equals, what corresponds to x on this side? Here's the shorter side, so equals 15 over 24. And we can cross multiply and solve. If you can reduce first. If you don't have a calculator, and reducing helps. So this reduces by 3, so 5 and 8. And we can cross multiply and solve. 40 times 5 is 200. And divide both sides by 8. 200 divided by 8 is 25. Another thing, if you remember proportions, once we're to this step and we've reduced, we can actually think 8 times 5 gives me 40, so 5 times 5 gives me 25, so that's another way to solve it. They won't all work out that easily, but that also works. And let's look at number 3, and then the rest I'll leave up to you guys. This one is a bit different. We could try looking at 8 over 20. So 8 over the whole thing, 20. Short segment compared to long segment equals, well, what would go with 8 over on this bottom side would be this right here, which we don't know, over 25. So that's not working out very well. We could continue to go this way and figure it out, but there might be a better way to do this. So we want to find this x. So maybe what we should have done is we want to find this x. Let's make it an x right here. And so what corresponds to x is this side right here. Well, we don't know that side, but we do know the whole thing is 20, and this part is 8. So we can find that missing part. 20 minus 8 is 12. And now that we have that, we can just use the 12. So this segment over the whole thing of 20, 12 over 20, equals 12 corresponds to this x over here, x over 25. And now we can solve this. Again, we could reduce first, since I don't have a calculator. 4 goes into both of these. 4 goes into that 3 times, and 4 goes into this 5 times. Now we can cross multiply. 5x equals 75. So x equals 15. So you can use those ideas to help you with 4, 5, and 6. The next part really is the same idea, except these triangles really aren't finished off. So if we drew this, we have triangles, and now we still have the same idea as before, that we're going to have some proportional parts. So I should have mentioned the proportional parts really means, I talked about A over B equals C over D, but in our proof we also said like C over C plus D equals A over A plus B. And we also could figure out that B over the whole thing equals D over the whole thing. So we have really 3 different situations that we can use. We can use the entire side or just the parts of the side. And that's going to come into play here as we think through this. So the theorem says if 3 or more parallel lines are cut by 2 transversals, the segments are divided into proportional parts. So let's say we have parallel lines cut by transversals. Let's say this is A, so that's this segment A. This segment is B, and this whole thing, this whole length is C. And then over here, we'll call this D, we'll call this E, and we'll call the whole thing F. We have lots of different ratios we can write here. We can say A over B equals d over e. So that's one of them. I'm going to stop using the colors because it's a pain to keep switching. We'll just keep red. Then we could say a over c. So this short part over the whole thing equals d over f. And the last one we can say is b over c. So looking at our messy figure here, b over c equals, what corresponds to b? Well, that would be e over, and what corresponds to c? That would be f. So we have these three different proportions that we can use. All right, so let's see if we can use them. Number 7. I always think these are kind of written funny because it's hard to see what they're pointing at, but this one, this 12 comes here, and it's supposed to hit here, although it's uphill a little bit. And then this question mark is this length. All right, so can we use one of our proportions to find this missing part? So the missing part is right here. And so what I like to do, I like to start with that missing part. So I'm going to say x, which happens to be this whole thing here, x over 14, which is this part, equals the whole thing, which is the 12, over, and we have to be careful what corresponds to 14. So look at the 14, look straight across here, and this one corresponds to 14, which we don't have that written there, but we can find it because the whole thing is 12. This part is 4. 12 minus 4 is 8. And so we can now put that in there, and we can cross multiply. 8x equals 12 times 14. Again, I don't have a calculator, so I'm not multiplying that. Then I'm going to divide by 12. You could multiply it if you have a calculator, or you can figure it out without a calculator. I believe it's 168. But divide by 8. The nice thing about not multiplying it yet is I see that 4 goes into this twice, 4 goes into this 3 times, 2 goes into this 7 times, and 3 times 7 is 21. Now again, you could do that with a calculator. That's no problem. I just don't have one with me. So that is how you set up those. You use one of these proportions, and be careful to maybe find a missing side first. Like in number 8, I'm just looking at this section here, you can find this length right here is 7 minus 4, which is 3. And then you can use that to help you. So that often happens. In this one, you know these two, so the whole thing is 9. So maybe on these start off by finding, using the two that you know to find the other part. That might be helpful. So that's that one. And then the last theorem, this one was a little more difficult to prove. We're actually not going to do it here, but it says an angle bisector of an angle of a triangle. So notice in all of our questions here, 13 through 18 all have angle bisectors. It divides the opposite side into 2 segments. Well, yeah, I see that. Divides it into 2 segments. All of them divide into 2 segments that are proportional to the other 2 sides. When it says the other 2 sides, this side's being split, so it's proportional to these sides. And so I'll show you how this works in number 13. These are pretty straightforward once you have them down. Like the other examples before, or theorems before, we could have seen in different ways, but this you really see the same way all the time. So it says 10 over 6. So these 2 segments, 10 to 6, that's proportional to the other side. So the way that you know 10 is adjacent to the one that's missing. So since we have 10 on top here, we're going to have x on top over here, and then 6 goes with 15, and then you can cross multiply and solve. So 6 times x equals 150, 10 times 15. So 6 times x equals 10 times 15. Divide both sides by 6. Figure out what that's equal to, and that's equal to 25. So there you have it. Those are the 3 theorems from this lesson. Please complete that worksheet. Obviously show your work. Thank you.